Okay, well, I guess it's just us tonight. So, here's kind of the agenda for tonight. Todd's going to go over the communications tools, and Carl, I'll give you some time. You can fill in what Todd misses.
Okay.
Then I'll do kind of a general update. I got a couple of slides. Then we'll go over the team status. Then we can open it up for discussion. So, Todd,
yeah,
you want to start out?
Sure. Is there easiest way to do it? Is there a way for you to pull up the email I sent out earlier? Since your computer's already hooked up?
Yeah. It'll take
forever. They finally updated.
Yeah. It'll take a minute. This machine.
Not a problem. But basically, I had, first of all, is everybody getting the emails from encs.humanoidroboticsproject@gmail.com? Okay. So you should have all the links. I sent all those out today. Basically, there's a link for a Google Plus page, which really, that's just for posting updates and status, things like that. More important, there is a link for our forum. Now, you need to actually click on that link. If you haven't already been accepted as a member of that forum, the forum will tell you you need to be accepted. You just click on the link. I'll get an email, or one of the owners will get an email, and then we'll be able to add you into the forum, and then you'll be able to post and write and do everything you need to. But it's a closed forum, so it's, you know, either by invitation status, invite only, or you ask to be allowed to be a member of the forum. And that is, when you first click on that link, if you're not a member, that's what you're going to see. You're going to see a message coming back saying you're not a member. Click here to ask to be a member. Okay. If you still have a problem with that, just reply to the ENCS email address, and I'll get it and I'll take a look at it. Or after our meeting, we can talk about it and look at it as well. I can send invites out, and actually, Rodney, you actually sent me a request, but you were already a member. So, because I can, you know, I sent invites out earlier to the team leaders and the core member people, and not everybody accepted it. They probably didn't see it or whatever. So I can't actually directly add you as well, and we can take care of that this evening if we want to. But that's the key thing. That's our forum. In that forum, the team leaders can set up topics for their groups, or we can set up other topics, things like that, and then, you know, we can create our threads, have our discussions going back and forth on that forum as well. There's also a link in there for the YouTube channel. Currently, right now, this meeting is being streamed live, well, with about a minute delay, through the YouTube channel. I sent an invite out to everybody that has a Google Plus webpage, and I've been able to add as a follower of, or I'm following off of our robotics Google Plus webpage. Sent an invite out on that, but actually this one is actually a public one as well. So if someone out there were, you know, just bored, they might actually see this on the Hangouts on the air. So they could sit here and watch this, and I doubt they'll get a lot out of it, but they'll see it. At the end of this, when I stop, I'll be able to, this is recording the video as well, I'll be able to upload that video to YouTube. So if you weren't able to attend the meeting and watch it via streaming, you can go back later on and look at the video on the YouTube channel. I think I've also noticed that someone else had actually posted I think like one of the first meetings that was held onto our YouTube channel as well. I'm trying to think. Attached to the emails, there's our Twitter account. So now what I'll do is if you have a Twitter account, you subscribe to Twitter, you follow that feed, we'll put the meeting updates, any notes like that we need to send information out to anybody. Likewise, if there's something cool, that's popping up in the robotics world, I may throw a link in there, something like that. I'm not the only owner of those accounts. There's multiple people that are owners of those accounts, and we can discuss how we want to open that up. Or obviously, if you're following it, I'll follow you. You can always post to your Twitter account, and it'll show up on that account as well. I have gone and changed the signature on the email, so all of those links are now on every email we send out. So those URLs are down there. Now, and Carl can talk about this with the wiki, but one other thing, Grayson has talked to his contacts with the IEEE. What we're going to try and do is get a static homepage with an IEEE.org address associated with it. And then we'll use that as a static web page. We can put all these URLs on that web page, and then you can access any of these pages via that IEEE web page. Likewise, we can get Carl's, the wiki address, stick that on there as well, and then we'll have a link to that.
And there's also the Git repository as well.
Yeah, and the Git repository. Yeah. So I have not done. Got the name today, and just need to contact IEEE and talk to the right people about getting a DNS assignment for that. And I'll talk to you, Grayson, in order to make sure we put the right name we really want associated with it. Again, I started off at Humanoid Robotics Project, and we've also got Humanoid Robot Project. So we'll figure out the proper name. We'll create that. Once we get that, I'll send that out with everybody's email. Key thing though is making sure you're getting the emails, because that is the easiest way I have with communicating with everybody. And likewise, if you don't have a Google Plus account, even if you just want to create a dummy account just for the duration of the project, please do that, because instead of streaming via YouTube, we can go straight through Hangouts, and that's more real time. I don't know why we have this minute delay here. It could be just it's inherent in the live streaming, because it's a broadcast. It's not a two-way conversation, whereas Hangouts is a two-way conversation. And the other key thing is I attended a meeting earlier, I guess it was or late last week, with one of the groups, and obviously sitting down and meeting face-to-face is the best, but if you guys and your groups can't get together in a location, you can always use Hangouts to talk to each other, to kind of go over things and stuff like that. And there are lots of tools that you can attach with Hangouts, like whiteboards and things of that sort. So there's a lot of tools that you can utilize using Google Hangouts. And of course, I'm not a Google advocate here. I mean, I know Skype just started allowing conference calls in the non-paid accounts.
I already had a conversation with the other two guys in my team, which are both in Charlotte.
Yeah, that was the main thing, because we have one guy in Charlotte, and this was an easy way for them. Yeah, this is an easy way for them to be able to attend these meetings. So the information is going out on the emails, and the URLs that are ready are on those emails. But again, some of them we just haven't really populated anything in them yet. Again, a lot of them are kind of sort of like advertising. The Google Plus web page right now, we could open that up to anybody, and we could use that as our advertising. the forum, things like that, are closed to the project members. And then getting with Carl, adding those extra links in, and I think using the static web page that we would get from the IEEE.
Well, we can get rid of the static one that I did.
Okay.
But
you utilize that one.
The other thing we need to do is, it would be really good if on that machine that we get separate domain names for each one of the services we put on there. So the one for Git and then the one for the wiki.
Send me a name.
Yeah.
Tell me what you want.
Well, you can just put wiki for the wiki one. So WIKI dot whatever, right? And the other one you can just put Git dot whatever.
Yeah. We can talk about that.
Yeah. And then we'll be able to get it here without any problem.
Yeah.
But you're not going to be using a board anymore.
Okay.
In that case.
And I have looked at some other items from, because there is actually a Google's project template that, unfortunately, I couldn't adapt the existing web page that we have to utilize it. But if we come up with a different name or something, then I'll probably look at that template. And that in that template, you have calendars, you got the ability to put documents in and all those types of things. I have talked to Grayson about, with the Google Plus account we have, that does have a Google Drive account associated with it. So we can utilize that Google Drive account to upload documents. Again, that's another key thing. If you have your own Google account, you have a Google Drive account, what we do is you share exactly, shared folders. And that's an easy way for you to be able to, put documents in and not eat up all your Google space,
right.
In your Google Drive, and we can share documents that way as well. And then you don't have to actually have a login specific to the Google Drive for the Google page that I've created. We just created the share folders. So between that and Git, we should have both the capabilities of being able to pass documents back and forth. I think even on the forum we can attach documents and things of that sort as well. It's a matter of, as I call it, playing around with it and figuring out what our limitations are. But first, let's see if we can all get in. And I would ask the team leads to go ahead and probably create a thread specific to their groups. And, they can, whatever action items, whatever things they need to put in there. And that way I get feedback, because currently I'm not really getting a lot of feedback, and most of the time I'm actually talking amongst myself amongst about 3 different computers with about 3 different Google accounts signed into it, and it's not always working out like it should be. So I'm wondering, is it just doesn't like it that I'm all coming back to the same IP address or something? I don't know. Today, like I said, right now what I'm doing here, I'm actually, taping it with a webcam, but I'm monitoring it on my iPad. So this is the Google account for the robotics group. This is my Google account, so I'm actually able to see that I am streaming the video over YouTube. So that's my monitor. And that's where I'm detecting the about 1 minute delay. And I don't know if, like I said, the delay could be a buffering issue, or it could have been just I hit start a minute late and it starts playing the video from when it first started recording it. So, all right. Any questions? All right. Not a lot of people here, so I'll probably have to do this several more times and more meetings. But actually, good thing to do is I'll start putting some information in the forum. A bunch of how-tos. Maybe that's the best way to do that. We'll start to create some how-tos or some stickies in the forum, so people can access that information in the forum as well.
Yep, that sounds good. And I would encourage you to try to get logged in and get used to, because we really, particularly the forums and the wiki, is a great place to put things and exchange ideas online without sending lots of emails back and forth. So then everybody can see it and comment on it and stuff. So So hopefully we'll start using that. I think everybody will find it very valuable to do that. Carl?
Well, did everybody get my email that I sent out, I don't know, maybe over the weekend, mentioning that the Git repository was up and running and everything? I sent it out to whatever the list was. Do you actually have an email like server running on one of your boxes or something?
I have an
It's an
email
MP.
server, yeah.
Yeah.
Well, what I'm wondering is maybe we can use the Google Hangout thing. I'm not sure how that works in this case. If there is like one email address that we can email to, and that email address then sends out email to everybody in the group, so everybody doesn't have to know who everybody's email address is to do that.
Todd, do we have access to your list?
Is there a way to do that?
I can set that up so that the team members or the team leads have access. I mean, I get basically
The whole team
I
should be
get
able-
the account and password to everybody, and everybody can log into it. And basically, I have all the members set up as contacts in Gmail, and I also have all the members have groups created, so all the members are associated with their group. So you could pick a group and just send it to the group or whatever. That's how it's set up right now. I'll also take a look because there may be a way that, like in the forums, when you subscribe to the forum, if there are changes in specific topics you're interested in or whatever else, when you make a change, I believe that's going to email the group or all the members of that topic as well, or the forum as well. So, but we can talk about ways to do that. But right now, what I utilize is I've just got all the contacts in Google Contacts. I don't have a listserv actually created. But a listserv is the best way to do it, but I just don't have a listserv running or anything like that. I have noticed that there is I can't remember the name. It sounds like it's a Blogspot listserv option that pops up sometimes when I look at the forum. It's like I can look at the forum, but there's this other item that sets up. This says this is for listservs, but I haven't looked into it yet to see if I can build a listserv with it. Yeah.
Well, what I think though is that my point is that we probably need to have like one listserv we can send one email to when we want everybody in the entire group to get a message.
Yeah.
Otherwise, it's like, did I get everybody on that list or not?
Yeah. I know.
That's a pain in the butt.
Yeah.
That's why we're looking at this stuff. Because I was having trouble keeping track too. So.
Anyway, continuing. So what I've got, what everybody needs to do is they need to go to the wiki, and on there I have a special location right on the front page where you can get to instructions on how to pull and push code to the repository. So the team leads need first, what they need to do is to give me the name that they want the repository name for their project. I mean, Vision, I just named it Vision. I also was using the audio guys, and I just named one audio. We can change that if they want to change. They want to call it sound or something. We can remove the audio one and put in one called sound if they want. But the other teams, they need to send me a name. It can have underscores, cannot have hyphens, and it should all be lowercase. And I'll set up I have to set up something on the server side. It's actually called a bare repository. You can't, it's not a working repository. It basically just has, so anybody ever see a Git repository before and what's involved with Git? There's a directory in a Git working repository called .git. The dot in Unix makes it invisible, so you don't normally see it with a normal ls. So inside of that is where all the actual repository is stored, okay? Outside of it is a working area. Well, on a server, you don't need that working area. So when you create it as you do a bare install is what it's called. You do a -- bare init. And it creates, so your primary directory is actually like that .git directory. So then what needs to happen is whoever is the lead of the group needs to make one on his machine at home, needs to make, and I have the entire list of the entire process you need to go through. Every command you need to run, and in what order. So it should be pretty simple. It's a little bit more complicated to do the one at home because there's a lot of stuff you've got to do to make sure it's linked to the proper origin, because the origin is his server. So you don't want to link it to the wrong place or not have it linked to anything. And then what you do is you put 1 or 2 files in there and you can just do a push and it'll automatically go up to the server that he has. However, the first thing everybody needs to do is they need to generate their SSH keys and they need to send me in a file their public key. Do not send me your private key. As soon as you do that, you've opened up your machine to somebody breaking in. So do not do that. Send me your private key, your public key, I mean, in an email. Man, I'm screwing this up. So send me, they both start with P. So send me your public key, and it's actually on a Unix or Mac, it'll be in a .ssh directory. After you generate the key, it'll be id_rsa.pub. That's the one you want to send. So what you want to do is rename that, put your name in front of it, then id_rsh.pub at the end. The reason why is that when I dump them on the disk, if everybody sends me the exact same file, they're going to overwrite. I don't want to do that. So then when I get that, I can stick it in what's called the authorized keys file on his server. And these people can actually use SSH to pull and push code to the server. Eventually, I'm going to set it up so people can pull code. Anybody, because this is going to be an open source project, right? So anybody should be able to pull but not push code. And that I'll have to use the actual Git server to do that. I haven't set that up yet. That's that port that I had to open. I haven't actually been able to do that yet. So there's a little bit we need to go through in order to get this set up. But once it's set up, you don't even have to put in a password or anything to push and pull code. The key is what does that. So one person has already sent me his key, the guy that's in Charleston, one of the 2 guys in Charleston.
Charlotte.
Charlotte, Charleston.
Charleston.
I'm thinking Tennessee. I used to live there. Charlotte, right. Once again, starts with a C. Other than that, I haven't seen any activity at all on the wiki other than me. People need to use it.
I tried to use it the other day and was still having trouble. I haven't followed up with you on it, but I couldn't create a page.
Did you?
I previously sent you an email saying, activate my account.
And I should have acted. I can't check it here, unhappily, but
right.
The only way to check it is actually to SSH in.
When I get a chance, I'll
send me an email to remind me. Otherwise, I'm going to forget.
Yeah, I just haven't followed up on it.
So that it wouldn't let you create?
It behaved the same way as when I first created the account, and I went to try to create the page. It says you don't have permission to create pages.
Oh, really?
This time. Yeah.
Huh.
So that's all right. I'll shoot you an email to take a look at it.
Has anybody else had that problem, or has anybody else tried? I don't think anybody's been out there. But anyway, Yeah, I know, you said everybody was bugging you about getting up a website, and then once we get it up, nobody's doing it.
Yeah. Hopefully we'll start using it now, I think.
So, I mean, send me an email if you have any issues with any of this. I'm hoping the procedure, I mean, I've gone through that procedure myself. I've created an account, figured out what the procedure was, stuck it in the wiki, blew away that account, and recreated it directly from reading through the wiki, and it worked. So, but I have extra special permissions to get into that box, and that could be allowing me to do things that it may not allow you. I need to know that. You know, I think I've solved that problem, but I'm not 100%. You don't know until you get 2 or 3 people trying it. So let me know. That's it. I'll shut up.
Okay. I'm gonna put this little update in the local chapter newsletter soon. And I wanted feedback from everyone. Is there stuff in here that we want to add or change, or I want to start gathering up some more active bodies to work on the projects.
You just wanted AI?
Yeah, that works.
Yeah.
It's like,
So actually it becomes AI Git on the server, but that's not what you'll see locally.
looks good to me, Grayson.
Okay.
You just need a web page. Put something
Yeah,
down
right.
there.
You can see our website.
Have you generated your keys? You got to do that. So you're running Windows
Windows and Linux.
and Linux, so you could technically do it on both, and I can put both sets of keys in there.
Okay.
Windows is a little bit more complicated to do it. You can
I primarily use my virtual machine. Linux.
the Linux virtual machine. Well, if you use that, then it should be pretty simple.
Yeah, I'll get that. I just haven't had a
I
chance.
mean, it tells you on the wiki exactly what to do, where the file is, and rename it, and the whole thing.
Right.
So,
Yeah.
okay, great.
Okay, no feedback on this one?
I can't read it, so I don't know do it. I haven't looked at the newsletter. When is the next, I guess, chapter meeting? Just there's
Chapter
PES
meeting
and
or
everybody
the
else. but-
Newsletter. The newsletter is supposed to go out twice a month.
Yeah. I was just wondering when there was the next generic chapter meeting, Eastern North Carolina
Usually
section.
the third Thursday of the month, I think.
Yeah.
is-
I'm just trying to remember because I'm signed up for the EMC one and the PES fire group, and I'm trying to remember if I had seen a general meeting, because obviously that's a good place to bring it up at the general meeting as well. Again, because I think that's where I heard it the first time. So.
Okay, well, I can show you afterwards, Rodney. Okay, I wanted to we've talked a lot about the goals of the project and stuff. I just wanted to do a quick kind of make sure everybody's on the same page with the architecture stuff. Essentially, kind of how it's fallen out here is we basically have 4 major teams. And my expectation is that each team is going to work fairly independently. So you have some basic goals, right? You're going to go out and kind of solve those goals. Now, what we need to talk about as a team is that each one of these boxes or teams needs to communicate what information they are able to gather and what information that they need that would make their job easier. Because essentially, any box can talk to any other box. It's an any-to-any type matrix here. So the vision processing team, you may be able to identify people in the room and tell AI who we're talking to. You may want to tell the speech guys who we're talking to, because if they know who we're talking to, it may help them to identify the speech pattern of the person that's talking. So information like that needs to be exchanged. And the vision probably will want to tell the structure, I want to look in this direction, or I want to do a certain movement to get a better view of what I'm looking at. The AI team is collecting a lot of this information, and then he's going to be feeding back to a lot of the teams what they have collected and what they know about what's going on in the room. So the AI team may be able to tell the vision team, there's 4 people in the room and I know who 3 of them are. That will certainly help to reduce the facial recognition problem. If you know it's one of these 3 or 4 people, you can use those and target those when trying to do your recognition. So,
one of the things I did actually over the last month is I downloaded and read the ROS book, the Machine 4 Robotics Operating System. And actually, it's a pretty good book. I actually read it from beginning to end. And they describe how they do their communication within ROS. It's very similar to named, I'm trying to think of
Named pipes.
named pipes. Very similar to named pipes. It's not really named pipes, but it's their own internal structure methodology. But every subsystem say, I'm broadcasting out to a named pipe. And anyone can say, I'm listening to named pipes. So there's a many-to-many correlation. There's no requirement for anyone to even listen to a pipe if they want to. You can listen to a pipe that hasn't been created yet. Just hoping to be created in the future. It's not really using named pipes. It's very similar to that methodology under the covers. It's pretty neat, actually. It actually showed an example of two video cameras. I was surprised. I was surprised how fast it was. The 2 video cameras, each broadcasting out to this named pipes, something else receiving from both these 2 cameras, and doing the side-by-side analysis and creating the differential view of the 2, and writing out another pipe, and someone actually listening to that pipe and actually viewing it on the computer screen, all on one PC, and I was impressed. I haven't tried downloading the code to try running it, but I definitely want to go that route. But it seems an interesting way of solving communication problems. I know people were investigating when the times past, whether they were with it or not, but I can definitely worth reading the book, the ROS programs, neurology book, so they can't fit your model, what you're describing here.
yeah, well, that sounds good. I know Steve's been looking at ROS and figure out how, where it matches and where it doesn't. So, but my challenge to the team leaders is figure out what information you can provide and what information you need from the other teams. And then we'll figure out how it's going to get the actual mechanism for moving the data. But the teams need to identify, and that's probably a good open part of our open discussion later, although not a lot here tonight. But we need to start talking about, what data do we want first, and how are we going to get it, and what data can be returned that will help you in solving the issues that you're trying to solve within your particular team. So I don't think there's any magic here. It's all stuff we've talked about. So, but I just want to make sure that each of the team, is going to solve the problem, and you may have unique processing requirements and or hardware requirements, and we need to work with together to make sure that we can get everything integrated, but go ahead and start getting things going. The other thing I wanted to talk about is the end of next month, we're actually almost halfway to our goal of having something for the end of the year. So I'm getting very anxious to start getting some more stuff together, even if it's very primitive. If we can start tying some pieces together and start making, getting a little bit of communications between the teams, I think that will be very valuable. I mean, we can study this problem for a long time, but the quicker we get trying some things, we will quickly discover the fact that we hear ourselves talk and things that, may be obvious, but nobody had thought of them. So I'm going to be pushing to try to get some pieces together and start, trying to connect stuff up, get things going. So I think this is any questions or. So I think let's roll into the status and we can start talking, more specifically what each of the teams is doing and where we're at, and think about what we can do to, start putting something together that we can demo, even if it's very crude and very primitive. But I want to start getting the pieces together. So structure team.
Yeah, where we left off at, so where we left off at last meeting, if I remember correctly, was that we decided that we're going to start working on it next, and of course finishing up phase one. With that, we have gone back to revise phase one just a little bit, to make it more integratable with the neck movement. So rather than coming off at collarbone area, having cut off more at the skull, so it would stick out top of the neck. It won't be like a neck and then another neck on top of that. It's so that's not going to take long to wrap up. So we'll have that wrapped up in the next couple of weeks. Then this Brian, you want to talk about how we're going to move forward?
Yeah, we had a couple of questions. I don't know if they're really appropriate now or in our group discussion, but it's sort of the structure design from like 20,000 feet, and sort of these are just a couple of questions that we thought of, but it sort of sets the stage for how we're going to go into stage 2. So I've got a couple of questions, and we're just
I think this is great. A small group
Okay.
as well. Go through them. I think everybody will be interested, in what's going on.
Okay, sure, yeah. Okay, so our first question is after thinking about this in stage 2, when it gets time to think about actuators for these joints and things like that, do we want to use energy to energize that joint just to say hold the head up, or do we want to conserve that energy when the head's not actually trying to look and things like that, because that's going to drive some of how we design our stuff. So we're thinking, well, we don't want to consume energy in an actuator while the head's just there, only use it when it's doing that, in case down the road you run off of some low energy source. You just don't want to be hogging this energy just to hold the head up. Let's see.
Well, I got a couple of feedback.
Okay, sure, yeah.
First of all, I'm envisioning, whether this is possible or not, but I'm envisioning that the physical robot will run off a standard 125 volt power supply.
Okay.
So that we can take it places, we can plug it in, and it will run.
Okay.
Now, I realize we gotta factor in the computing power that we're gonna try to hide in the robot, and we've got actuators and stuff. But that's my goal, is that I can take it somewhere, plug it in, and it works. As far as the neck and the head being basically static, or unpowered during certain periods,
Right.
I think you will find that it will not be very realistic if there's not some motion. Almost everybody has some I'll call them ticks, but there's always some motion, there's movement, you're always looking around. Very rarely is your head going to be static.
Right.
So I'm kind of thinking you're going to be powered up
Okay.
most of the time. There's going to be very small, just twitches, movements. You're going to be looking, and I think
So would
you
you
look
expect,
around, people's heads aren't like static, you know.
would you
so
expect when you cut the power that the head slumps forward?
fall down? It may very well, yeah.
I mean, that's the balance point, right? You know,
Right,
are
that's what we're.
are you designing it so that it's balanced and you just kind of
Well, that's the
wobbling on the
thing,
balance
we can
point, or?
do- we brought this up, so we can do either or, and so we were saying that same thing earlier, you know, what if we pull the plug, is everything just gonna go, or do we need to make sure that if that event happens, that it can, you know, say, hold its head up, you know, or.
If it's
Yeah.
unplugged, and the head drops, the head drops. I don't have a problem with that.
We can always modify.
But I don't want to apply a lot of power to hold the head up,
Right,
you know.
yeah, we don't either.
Right. So you want it as balanced as it can be, but I think it's not going to be just kind of sitting there. I think you're going to have some control over it all the time. Right?
There's also the choice of how you do the gearing. Do the gearing itself, unpowered, doesn't, you know, like a rocket pinion versus, you know,
True.
I think it's actually, the gears themselves can be back powered and drop, they can be forward powered to display motion. I'm not saying you have to go that route, but there are options other than just one extreme to the other. You have a choice of how you do the gearing.
Yeah, true. Okay, good.
Carl? I think Carl's got a.
Yeah, sure.
So you mentioned that you were envisioning, at least in the beginning, that we would plug this thing into a 110-volt outlet. All right. So who is responsible for the power distribution, the power plant of this thing to begin? Do we have somebody that's going to do that? Generate a 24-volt line or a 12-volt line or a 5-volt line or something that everybody can tap into at some point.
In my view, the structure team is responsible for the hardware, so that
Okay.
would fall in there.
I wasn't sure because hardware and power are not necessarily in the same camp, but.
Right. Now,
But you just define an ATX power supply, so we just run down the, Tiger Direct and buy us a 700-watt supply or something,
yeah, we're not designing,
Yeah.
internal supplies or anything.
Well, but there also has to be, people have to figure out how they're going to do power distribution, what kind of terminal strips are we going to use? Are we going to use terminal strips? Are we just going to have a plug there for everybody like there would be on an AT power supply, right?
Yeah, all that.
We've got to decide all of these little
Yep.
things
Yep.
so that we can easily add stuff on and go, whoops, I need another connector and there's no place to plug that in,
Now, I know you guys are mechanical,
Yeah.
so if the structure team needs additional skills, you need to let me know.
Okay.
And we'll try to help you. Now, you're certainly
Yeah.
welcome to round up skills that you're familiar with, but if you need help, let me know and we'll try to round up some skills as well to help round out the team to cover all the things.
At least for the bus point, as we get further on, the bus point, the actual distribution will be relatively simple. So, and we'll decide beyond the point where we go. But for that, we've already been imagining a box under the head that contains stuff, so easy to have the distribution inside of there, power supplies inside of there, et cetera, and then have an idea what we're looking for. No need now to design the world if we don't need it yet. And iterative as you get to that point.
Cool. And the other question is we were talking, and so our joints, so these joints, we were thinking about building them in such a fashion or designing them in such a fashion that they will like interface each other. So if there's a problem with the head, so the head fits on a joint, here, and I can undo maybe like 2 or 3 screws quickly, and I can, unplug, a few things, back here, say, and then I can take this head and set it down and do my program and troubleshoot it. So our joint design, we were thinking, should have some sort of easy, quick, like interface so that we can put on, take off rather easily, and we just thought we could throw that out there and see what you guys thought about that sort of design from a 30,000 foot view. So.
I like the general idea. The only concern I had for the example of the neck is probably a bad example. I think there's definitely a way, like I mentioned before, having the eyes come out and go in place, work on those independently. Some of the opening the head to get into it. As far as lifting our head off of the neck, the number of actuators in the head will probably exceed the volume you have inside of the head to put all the motors and physical components. So the thought probably is there's some sort of actuators in the body cabling up through the neck. We mentioned before, it's like the what do you call it, the wire inside of it, the sleeve, like the bicycle gear shift type lever type things. Something similar to that. That'd be harder to dismantle that. You find a way of solving that problem, definitely. I suspect there'd be a lot of things in here, especially when the skin moves, etc. You run through here down into actuators, actually inside of the body. Until that time comes, it'd be very nice. So, but I think once we get to that point, you probably need to have more of a hollow neck to pass things through.
Yeah.
It's not like we're going to have a shadow like these things.
My comment is that I agree. I think the computing and the power supplies, all the weight's going to be low, so it doesn't fall over. We want to get that weight down in the base of the bust. But there is going to be a lot of wiring and cabling going up through that neck. So if you disconnect, you've got to have a good strategy for connectors that can be easily connected and disconnected, because you've got power, you've got signal lines, you may have physical control lines.
And you're going to need different kinds of connectors for different types of things.
Yeah.
And you get more than just electrical lines, so there's probably possibly mechanical lines to pass through there as well. That'll be the hardest thing I think that's going to happen. But actually, I'm not saying no, if you find a way around the problem, please go forward.
Well, one of the things that we thought about for the joints is a lot of, we saw a lot of people online using U-joints, which are, not the cable and the wires that which seems to be the other way people do the same thing. Yeah. And so that's sort of what all I guess. So that's it. That's all.
Yeah, that's about it.
I think removing the neck itself won't be that much there. Once we get to the more final stages, it's laid down just to manipulate the skin and underlying muscle simulating facial movement. It's been possible to cure the inside the skull. This could be another phase. When you feel like you did the phase one is good with the very simple system. Do the phase two, you get easy access to the plug and move, etc. And a later stage is that you can pass control lines through. This is the reason as long as you don't have to do too much re-engineering starting from scratch. Those phases. That's up to you.
Okay. All right.
Oh, I like your phase one redesign. You probably should show them around. It's really good.
It's more of a soul now than lost.
Okay, we'll check that out. Okay, is that good?
Thank
All
you.
set? Okay. Carl, vision?
Well, one of the reasons why I got the Git repository working is because Sterling has actually produced some code. It's really in the beginning stages right now. It's just kind of testing out some ideas with facial recognition. And he needed a place to put it. So that's why I got it. So it's actually in there under Vision already. So if you were to actually clone the Vision repository right now, using the instructions on the wiki, you could actually pull down that code. I haven't, he just put it up like Tuesday, and I haven't even looked at it yet. I pulled it down in my box just to make sure I could do it, and that was as far as I got. So I'm gonna have to go in there and organize it and figure out, okay, what are all the different things we need to do in this code base? And that's something I've yet to do, but I've had nothing to work with now, until now, so. So now that I've got something, I can start to I have ideas. So, Sterling, myself, and Artie going to have another meeting, virtual meeting, sometime either later this month or early next month. And one of the things I want to talk about is all of the different sections of code that we need to write and how they're going to interface with everybody else and what kind of data we're going to be sending back and forth. We may not be able to ferret all of that out in one conversation, but so that's kind of where we are now. One other thing is that I would like to make a decision on hardware. There's a brand new camera that has just come out. It's called a Pixie camera, and it actually has and it's specifically made for exactly what we're doing. The problem is that it's on a circuit board that's about that size. So it's about 2 or 2¼ by 2¼ That's pretty big for an eye. All right, when you got the camera sitting in the middle of that whole thing, right? So, but it does exactly what we want to do.
The actual.
It actually does
surface
all
mount,
of this
or-
onboard computation for determining the distance to an object, facial recognition stuff. It does like all sorts of stuff, and it does it in hardware, which means it's going to be doing it really, really fast.
Yeah, I'm just wondering, can you actually take the sensor off of the board?
No, because once you take it off the board, you lose the board.
So you.
Yeah, there's no way. It's actually soldered
That's
right on the
is it
middle of this
surface mount, or is it through hole?
Here, let's see. I can actually bring it up. So
Through hole, you can take it off and then run wires back.
And if we contact them, they may do something. You never know. So we're
Yeah.
talking to them.
Yeah, I mean, that's what I'm really trying to figure out. If it's something you can remove
Can
the
you
sensor and then wire
physically
it back to the
move
board.
the array.
Or is it like just a flat CCD on a board, you know?
I'm trying to find it here. I can get Chrome. That's not Chrome. So it's created by Charmed Labs, CHARMEDLABS.com. And it's called Pixie is a Real Product for Real. That's not what it's called. It's just called Pixie. So this isn't actually the spec sheet. I actually read the specs. I've just found this now. So let's see, about products. That's probably about the company. So this is so that's the board. If you want to see what it looks like.
I can. It's pretty heavy. It could be surface mount, it could be through.
So you can see where the camera is. It's in the upper right quadrant of the board. So I don't see how that board is going to get removed from the. I mean, the camera is going to get removed from the board very easily.
Unless we use optics to bring.
No, then you're going to lose so much resolution and
Well,
definition.
I'll say, how much is it?
It's not cheap. It's like
Okay.
it's like $100 in that range per.
I don't know if we could just go ahead and buy one and find out what we could do to it.
Well, you see, that's a point here, and that is that in order for the vision group to decide hardware, we've probably got to buy some stuff and test it. And if we use it, we use it. If we don't, we don't.
Or is there a way we can utilize the purpose of the whole project to get samples?
Yeah, I don't know if this company will do samples. They may.
You know,
Ask.
Yeah.
Stencil them on the forehead.
Ask.
You know.
Yeah.
So
The last project I did, we got tons and tons. Companies were sending us all kinds of stuff.
Really?
if you might be surprised.
You gotta ask, you know? They have a lot of that stuff that they'll give out.
Yep.
Onesie, twosies, you know, if they think you're gonna buy more, or if
Or
we're
if
going
they
to-
get some type of advertising out of
If
it.
they get some advertising. They need to get something out of the deal, but
Yep.
most companies are very generous with giving your products out if they think that there's a chance that.
Yeah, it's not like we have a car and you got a big sticker you can stick on the side on your last project, but
But we
you
still
can have a wall behind your tail and you can,
we'll-
you know, these are the optics we're using, blah, blah, blah.
$69 per camera.
It's not too bad though.
It's not bad at all.
No, it's not. When you can, now this thing's got a whole bunch of chips right on the board. So, I mean, it's doing a lot of processing right there.
So what's the interface?
Yeah, again,
That's what I'm trying to say.
I'm thinking it's a through hole, because it is a big block with a camera on it.
But I'm thinking is it either.
And I can't believe that surface mount, so I'm thinking that's through
So
hole.
here's a good blow up of it.
Jason, you remember the CMU cam?
Yeah.
It's basically the newest version of CMU cam. It's
Oh, is it?
CMU cam number 5, it's called Pixie, but it's a continuation of that product been out for a while.
And if it's through hole, then it's possible to take it off and then we can wire the camera back to the board. Does it got a screw on it there?
We're not gonna solve it here,
Can't-
so.
can't tell.
If you think that we need one of those,
Definitely through hole.
let me know. and
It's on it,
We'll
so.
buy one.
Well, I need to talk to the other guys on the team and find out if there is a way to interface that into the software that we're doing. The software may not understand the data coming out of this. So,
That's why I asked what's the interface.
yeah, so that I don't know. I haven't had the time to
So
really
we'll
check.
do your homework. At this point,
Internet.
I mean, we don't have an unlimited budget, but I have a budget, so if we need parts, we need parts, and we're gonna need parts, so.
Yeah.
So I'm not freaked out that you wanna buy something, you know, that's expected. I just don't wanna buy a lot of stuff and put it on the shelf.
Could we do a what do they call it, crowdfunding thing on this? Is it
Are
possible?
you doing like a Kickstarter or
Like a
something?
Kickstarter, yeah.
Maybe, but
I
at this
think-
point, I'm
Start
working
asking
on
for briefs.
funding, and don't worry about the funding. You guys
All right.
get the thing built. I'll get the money. Yeah. So, so the other thing I was going to mention, Carl, is that just so we're on the same page, is my expectation is that you will store images and do the image matching within your component. So that if you've previously found person X and person X returns, you should be able to resolve that within your segment.
Well, it may or may not be the right place for it, because if a repository of people that this robot has already met will be important to more than one group of senses within the robot, then you maybe want a centralized location that be storing that data.
And we may decide to move those images out and stuff, but you should have a library of people that you can do matching against.
Well, yeah, in the beginning, I'd probably be handling more data than we would later on when we start to centralize. All of a sudden, we find that a bunch of us have overlap in what the data we're storing. No reason for the overlap, right? The drive principle, right?
Okay. Any other questions for Vision? Okay, Speech isn't here tonight. He's traveling. AI.
I got the picture, so if I can plug in up there.
Yep.
No. All right, so for this month's accomplishments, I guess, haven't made a whole lot of progress last month, but we did meet and review the proposed cognitive architecture and identified some gaps in that. And then we drafted some message requirements that we have between AI, vision, hearing, and proprioception, which is, I'm proposing, is maybe a new subsystem that we should consider. It has to do with sensing the internals of the robot. Our goals are pretty much the same as I reported last month. We want to improve the hearing to AI to speech integration. One of the integration works, other than we have this problem of hearing ourselves, so we need to figure out a solution to that. But we also really need to improve the hearing side, because the CMU Sphinx speech recognition engine is having a lot of trouble with accuracy. It doesn't really stand up to large vocabularies. It's very specific to the vocabulary. It would work fine for a command and control type thing where you have a fixed set of commands, but for an open-ended conversation, I think it's pretty weak for that. So that's kind of something we need to figure out. I still think we need to validate the cognitive architecture against some similar published architectures. I did a little research on that, just did not have the time to do much detail on that. But it'd be good to know that sort of what we're proposing, which I'm going to show in a minute, is in line with what people who spend a lot more time than us thinking about this are proposing as well. We still want to design the knowledge representation and storage mechanism. Scott's working on that and going to provide some ideas for us to pursue that. I'd like to initiate vision to AI integration. If you've got some code that's recognizing faces, we'd like to start talking about, well, how could we get that information feeding into the AI and allowing us to say, I recognize the face, therefore I know who this person is, therefore I can pull out the information I've recorded about that person and feed that into the conversation. So that kind of integration is what I'd like to look for. I added this last line, which is we really need to pin down our architecture and approach. I know in my mind I'm still having a little trouble settling on a solution because I don't feel satisfied with the solutions we've got. As I'm looking around, I'm still finding a lot of new ideas that are, the new ideas are closer to what I would want than what previous ideas I knew about. Some of the new ones that we just discovered in the last week are, deep learning and deep neural networks. That was something new that's actually since kind of 2006 or so, and then even up as recently as 2012, there are lots of new publications about this concept. Seems like a fairly new idea in the neural network or AI community. So I'm just learning about that. And this spatiotemporal multidimensional relational framework comes from a paper that Scott found that the ideas in it are very similar to what we've sort of thought ourselves would be appropriate for this brain. But figuring out how to sort of pin that down and say, okay, let's move forward with the strategy is something we're a bit struggling with. So it's a goal to figure that out. This is the AI architecture. The pieces in here were primarily proposed by Grayson, and I restructured the diagram a bit. We've reviewed this a couple times with the AI subteam, but so that those of you who haven't seen it can get the overview. We've got a system bus on the top where we're expecting messages coming through from the other subsystems. Those will feed into our AI input component, and AI will publish messages out from the AI output component. We do have a short circuit across there where there may be sort of instinctive responses to certain inputs that don't require cognition to provide, and so input may feed directly to output. But in general, we expect inputs to flow down into a conversational context or a conscious context of the robot, which is a database structure of some kind. We're still figuring out exactly what the structure looks like. There is concept analysis that happens there where we're trying to make sense of the information. There's a lot more detail we need to still work out at that level, but very high level view, we think that there's this idea of a conversational context. There's an smart archive feature that's sort of pulling things in and out of the top level context with our local database storage, which is kind of the larger massive information that the robot has available to it on board, and a similar replication of that same feature to a remote storage. So the robot can have a larger massive information stored offline that it can pull in to its local database that it can then feed into its current working memory, as you mentioned.
I actually have some ideas about how you can deal with that quite efficiently, but it's not technically easy, but it's possible. I can talk to you about it later if you want.
Okay, sure. Some of the other components, like the AI predictor's role, is to figure out, to basically, based on the information in our current working memory, what kind of questions do we need to ask? What do we need to query from our other databases in order to fill in the gaps in the information that we've got? So it will be feeding those queries to search engines that run on the other databases to pull in additional information. So if we've got partial information about somebody and our stored information for previous encounters can fill in those details, the predictor will create the queries, the search will pull the data out and bring it up to the higher context. So that's the basic architecture we've been reviewing. We did identify a number of things that we felt were missing from this architecture that we need to do more work on. Goal management is a big piece of it. How do we keep track of a process that the robot is involved in, such as a conversation, and where are we going with the conversation, and how do we set those goals and plan the activities to achieve them? So we noted some ideas on that, but goal management's a big piece. We felt that there wasn't a place anywhere in the architecture where we could see mirroring and emulation type behaviors fitting. Sort of you and me and how my actions are affecting you. There's some gaps there. And then there's the whole idea of expectation generation, which we thought would be a new component of the architecture. what is expected given the current understanding, and so on. So this is some of the analysis that we've done on the architecture so far. In terms of relating our architecture to other published architectures, I forgot to bring the paper, but Grayson provided me with a journal, an IEEE journal that had a presentation of LIDA, which is a cognitive architecture. I've recreated that drawing from that paper here. And so you can see, people have been thinking about this kind of thing. This is a fairly interesting architecture in that it does, you have your whole internal and external environment feeding sensory stimulus into a sensory memory. You've then got various memories that deal with your object identification, perceptual memory. You've got a spatial memory, episodic memories, declarative memories, and these things all feed into your workspace, which is essentially the conversational context. So there's a lot of relationship between.
I think you're gone.
I think I should have brought my PowerPoint.
The computer's been telling you.
Thanks, Todd. I thought it would last a few more minutes.
It went down to 7% just in the time you walked over here?
Well,
Did you not have
He was
it?
driving that external display.
you did see gaming series on here. It's a gaming laptop. It's an energy hog.
The battery's only there to survive.
But I bought it for the discrete NVIDIA card that's in it, so that we can run OpenCV and do all of our calculations on the video on the GPU instead of the CPU. We haven't gotten there yet. But
That's why he's a Mac.
that's why you use a Mac.
I got discrete video on that too.
All right.
Oh, good, didn't crash.
Did not crash. All right. So, so this architecture is interesting. One of the things that I think is important is that there are pre-conscious and conscious aspects to it. So this attempts to provide a model for consciousness based on global workspace theory. So the current situational model, the conscious cue contents, the global workspace, the sensory memory, action selection, and motor plan are all in white boxes. Those represent conscious things. All of the gray boxes represent pre-conscious, or work that's being done in the brain that's feeding into the conscious working space, but not really perceived by the robot itself. It's just things that are happening in the background. So kind of interesting, worth some study. Let's see if I have any more here. Come on.
You need to get these images up on the wiki when we finally can get you in there.
Yes. Yeah, this is all right now. It's a Google document slide presentation. I should be able to easily export it, import it, wherever. This is the other thing we worked a bit on, messages that we're expecting incoming to AI. So I tried to list out the types of things, to try to partition the work between the different systems, because vision and hearing, particularly, are doing a lot of artificial intelligence type of stuff, right, in terms of object identification and so on. So we're really looking for vision to do that, right? Give us the identity hierarchy of what you're seeing, what's in the scene, what's the location of things, the orientation, the color or color scheme, size, texture, solidity, transparency. If it's a person, what's their age, their gender. These are all things that can be visually perceived. Therefore, it'd be great if the vision system can provide us some of that. I'll come back to this. In addition to individual objects and their attributes, relationships between objects. Right? Those can all come in that information stream from the vision system. Hearing is very similar. We're looking for sound characteristics that may be speech or may be noises. In the case of speech, who is the speaker, what's the language they're speaking, the actual text that they spoke, the volume, the cadence, the tone, the pitch, the accent, the gender. All those attributes can be very useful for the AI to identify a person, and if you don't have all of them, provide some of them. Right? Provide whatever you can perceive, because we can store that and use that for priming the system later. If we hear the same cadence, tone, pitch, and accent, oh, well, we know it's that same person, even though we don't understand their language. Right? For noises, what is the noise? Car horn, door slam, those kind of things. We'd like to know those as well. The direction, location. If you know the source is the door, then tell us it's the door. That kind of thing. For proprioception, we'd like to know characteristics of ourself, right? If the AI needs to know what the body is doing, right? Who am I? What are my parts? Where are they? What are their orientations, the locations, the positions of the different parts of the body? Is my mouth open? Is it closed? Those kinds of things. Timestamp, power level, motor strain. I'm giving you an action to move, but is it working? Right? I told the head to turn. Is the head actually turning? No, it's stuck. Right? This idea here is just to try to say, this hierarchy is, the pieces of the body. Every one of them has a location, what it is, where it is, the orientation of it. That information would be included in those messages. We tried to think of some of the things that might be coming out of AI to the other systems. The primary idea here is priming, where we're saying, okay, based on other information we've assembled from our memory or from other inputs from other systems, we think this is the current situation. So that should then help the vision system, the hearing system, to recognize or should bias it toward recognizing things that are in that context. So if we know a person or thing is expected in our context, then the vision system would be primed to recognize things like that. Perhaps mistakenly, but hopefully helpfully. Similarly, speaker, the noisemaker. We want, to the head, we expect to send facial expressions and a direction of interest. So if the thoughts, the spatial processing of the AI suggests that something of interest is to the left, then we would say our interest is on the left and expect the head to move in that direction.
Right.
So
A loud door slam, the head should
right.
move in that direction to see what caused it.
Right. So hearing tells us, I just heard a door slam over in this location relative to the body. The AI responds with, I'm interested in that over there. And then the body responds to that. So in general, the idea is the direction of interest in the brain, that's where the body follows. Right? The body just goes wherever the brain is thinking is of interest to it. Okay? I don't know if any of this stuff is ready to show you. All right, so that's it.
The other thing I would mention is that the head is a good example of, you may get messages from multiple units that have conflicting requests. And somehow we're going to have, AI may say, look left, and the sound, you may hear a noise on the right. The noise people may send you a high priority message that says, look right, there's something over there, right? Right. So we're going to have to either prioritize or have some scheme for when you have multiple requests, how do we resolve those? And where do you actually end up looking?
There has to be some sort of weighted system that we devise that gives things certain weight as far as importance. If it hears 2 doors slam, is it going to keep doing this? That's probably not cool, right? So do we have to weight it and say, okay, this one was louder, that's the one you want to look at,
Right.
Or
there may be many other factors, such as our current belief about where we are and what should be happening in this situation, and therefore which of those events might be more relevant or more believable. Although there's lots of we want the AI to be able to consider many factors other than just the obvious ones, and particularly things that are remembered.
That's where we start getting into expectation, right? So if I'm sitting in a room that has 2 doors and I believe one of them's locked, both of them open and close at the same time. I hear them both open and close at the same time. The one I'm more interested in is the one that I thought was locked. How did that happen? Something unusual happened. Something violated expectation. So, there's a lot of tie-ins with expectation generation and goals analysis. Uncertainty is generally considered a bad thing. You want to try and lower your levels of uncertainty. And so things that violate expectation are indicators of uncertain behavior.
Right. I definitely want this document.
Okay.
You've put a lot of thought into this. You thought of things that I hadn't even crossed my mind. So
I'll share it.
Can you back up to the incoming messages?
incoming.
Yeah, that one. The only thing that I'd add to the comment is a lot of these things look like they're, somebody's accent. Might be uncertain, right? So you might actually say that, well, it's like 70% that he's Scottish and, 30% that he's Australian, whatever. And it's perfectly valid to want to express that, right? Because that actually factors into, well, we have this uncertain picture that we've taken of this person, and their tone of voice is uncertain, but we balance all those uncertainties.
Thanks for bringing it back, because I said I would come back to it. I've got listed here hypothesis ID. The idea was that you could publish multiple messages for different hypotheses, right? With the different confidence, right? I think this is what I'm hearing, hypothesis 1. Oh, but it could be this other thing, hypothesis 2. With different, in that, all needs to be taken in. So, good, Scott.
And real world is not usually binary. So my expectation is almost everything will have some type of confidence level with it. And it's like, oh, I'm really sure that this, or I'm not too sure, or I'm guessing, but all these things are going to be weighted as to how you got them and
Well, I mean, over time,
how confidence you have that they are correct.
over time, we're going to have to come up with a weighting system that's universal throughout the whole robot that can weight the audio, the visual, everything together. And there needs to be, the robot needs to actually generate its own baseline. It needs to take in the full range of loud noises, low noises, light, very bright, very dim objects, this type of thing, and then figure out from what it has acquired in the past what the median is that it'll create its baseline at. So you want to determine if it's light out, what do you determine it from? Completely black and or an 100% washout white, or something else?
Right.
Well,
you'd have some vote from the vision system saying it's rather light out. I'm seeing a window, I'm seeing outside, it looks light. But then you also got proprioception telling me, it's 3 in the afternoon. So that likely means it's daytime.
Right. What happens if you have an eclipse?
Well, I've got that.
Expectation violation.
Yeah, it's like, why is it dark out?
Right, exactly. Expectation. So regarding, you were mentioning about sort of coming up with sort of the plan, and on this architecture, there's this idea of coalitions, and you've got attention codelets, which are like little programs that are sort of looking at, paying attention to things in your current workspace. Right? There's lots of information available, but your eyes and your mind are sort of floating between them. And those are forming coalitions, which is a hypothesis about how things are working based on what you're paying attention to. Oh, I'm seeing a chair, it's a desk, maybe this is a school. All those ideas get lined up, right, together. And that forms a coalition, which gets added to your global workspace. But you may have ambiguity in your situation, where you could look at it different ways, and those become different coalitions, where the ideas are consistent with among themselves, but there's a whole other set of ideas which is also consistent with the data, but not with the first set of ideas. Those are 2 coalitions. And then those get added to the global workspace. The global workspace then does some selection, saying, okay, well, which one of these coalitions do we want to choose right now? and it has some way of working that out, and then adds that to the conscious content, broadcasts out, say, this is what we believe is going on. But that could change over time.
Realize how incredibly complicated this problem is.
That's right. Okay.
This is not easy stuff.
All right. Anything else?
No, that's great. Any questions for Daniel?
Scott, did you have anything else?
No, I think you covered that. You got it covered.
Okay, so nervous system isn't here tonight and test isn't, so that's what I had there. So I guess what I'd like to do next is kind of what do we see as the rollout, or what is the timeline for making progress here? We've spent a lot of time looking and stuff, but we got to start doing. So I'll start with structure. When do you think we will have something, or kind of do you have a feel for what your rollout is, or intends to be?
As regards to just a static frame, it's basically ready to go. This will be done within 2 weeks. The static frame. As far as the neck, what do you think, Ryan?
So that being the head?
Yes.
Okay. So we still have the shoulders, the bust, and the neck, right?
Right.
Well, I mean, this will be just a slice of just this here, So what we had discussed was, we could export these files out to PDFs, DWGs, DXFs, and I think it's Alan.
Yeah.
Right? Alan and his place, they could produce those shapes out of the appropriate plastic or whatever that he has on hand. But as we talked about earlier, there was this little change back in there, so that if going into phase 2, we hit some roadblocks, at least we could sort of integrate that joint, down here onto this. So as you can see, we're sort of at the end of this phase 1, ready to export these files to Alan for him to get them produced and start into phase 2.
Okay. I'm not sure that it's worth building them quite yet,
Right.
because nobody really is pushing for that. So, and if there's any changes based on phase 2, then go back and tweak it before we actually build it. So I'm more interested in phase 2.
Right. In phase 2, we've got to do something with the head. I mean, as far as fill in more of the volume. We were looking for sort of a skull file in CAD that was pretty good that we could work with. You had an idea.
Maybe we need to define phase 2.
Right.
So what's your expectation for phase 2?
My expectation of phase 2 would be to, based on what I've gauged, is to have a more humanistic actual head shape and then a joint here. And that's just essentially phase 2 is what I understand.
Okay. You can jump in, Rodney.
Basically, that was what was decided for phase 2 initially. Basically, was to do phase one was something that we can hang the vision off and the hearing off, and if they needed it quickly. And the thought was they would need something to start testing spatial for hearing and the spatial for the eyes soon enough that they can have some sort of full test framework, and that just finished out. That's why it was created so quickly first to have that. Turns out actually they're probably finished with the next phase for actually what needs what's been done here. Now phase two is to get back into not only building a head, but building a skull that you can layer things over. I know what you're heading for is you're looking for the neck. That was actually not initially in what was in phase two. You can reprioritize it and do that. I think you want to head down there, you want to see the neck first. But the goal basically was initially was phase one was a static head. Phase two started adding more to that. It wasn't neck wasn't until a later thing. Was the thought was initially why I understood it was just it was a static thing sitting on a column basically. Now we can go to do the neck as the next phase instead, so it could be based on phase one, using that as a standing point. I know you brought another team member in whose interest was on the neck. I was under the impression everyone in the team had gotten that email saying a couple days ago, and I was that no one else had gotten other than me and Alan. So the miscommunication dropped there. I'm trying to ask you guys if they communicated with the new guy yet, and they had not, but they weren't aware he even added to the team. Okay. So there's a drop on my side and Alan's side. I thought I didn't see he was on the two email when we sent it out as a new team member. Unfortunately, he's not here tonight, so we can't actually discuss it either.
He was signed up to come, so I don't know what happened.
As you were saying before, you just thought was work on the neck area. And that's true if he does pick the neck, actually can do the neck independently. That would lead these guys to continue on the direction they're heading with. Well, initial phase two for them is just a better skull. If we find some way that those two and the new guy can interface together to do something that's cohesive in the final product.
I'm open for discussion, but I would like to see the bust and the neck, and instead of working on the more of the texture of the face, I'd rather get the more mechanical stuff done, because we can start figuring out how we're going to hide some equipment in the base of it and power and get the power up. But then as we get more stuff from hearing and vision, we can start working on the face. But my preference is to get the more mechanical movement. One, I think it's going to be challenging, and two, I think going forward, it's a much better visual to be able to move it and have the motion and stuff that we can show people that, we're making progress.
An idea just popped in my head. It's really far down the road, but as far as hiding stuff, do you think we could just buy like the top part of a mannequin or something and just cut off basically the head, the hunter, and like just mount whatever that shoulder such over all the components so it's more or less hidden, and then put like a coat over it or something?
I wasn't thinking mannequin, but I was thinking something very similar.
There's people actually that know that we know that can produce the equivalent of a bust fairly easily. If you have something on the neck to actually fabricating this, not just sort of mobile plastic, is not difficult without buying a mannequin. And that's just, the answer to your question is yes. It will be purchased, but not basically buying a mannequin break it apart. They could be furnished easily enough, yes.
Just want to throw it out there before I forget it sometime.
Yeah.
So at what point will we have a computer model that can be animated? Because we need to work on sort of expressions and, saying move this way, look that way, synchronizing mouth movements with speech. So having a computer model that we can animate would be really handy.
I've got a friend in computer animation and game design. I'll see what he can do, but I mean, he's over in ECUs, I really don't know. But I feel like that would be more that realm of visual arts. Yeah, it's definitely our area of expertise.
But I see that as more of solidifying the interaction between the AI and the structure main program.
Right.
And then the back end of yours, Rodney, can you talk to either the hardware or to some animated?
In fact, it fits into a very first conversation we had. The very first conversation, I envisioned the head being nothing more than a TV monitor with actually a 3D model basically there and solving those problems first before fabricating anything.
Right.
But basically, very similar to run the physical model. I do think I agree with you, both are needed. Unfortunately, it'd be a separate task, and it's no way to do that. So the construction team was doing it. I think it's a great idea. I don't think there's anyone actually here to do the 3D side of things yet to do that.
We need some bodies, right?
It's somebody that's good at Blender or something.
So,
Because I guess I just want to make sure that, for those kind of animated features, we need to know that the response time of the actual structure and its actuators is going to match, what we tune our models to. So if we just take any old animated face, we can figure out a lot of it, but we still have to figure out the model that actually drives the real structure.
And by having a model, you can simulate what it in order to have a second to work, versus an 8 the second to work. At what point does it become creepy or become unreasonable? You can simulate all this stuff out with a real model slash fabricating. You want to crash a motor that's too slow or not accurate, etc. So yeah, I definitely agree that's something needs to be done, no question.
Particularly as you start getting to independent power systems, being able to do modeling and testing, dynamic behavior versus power consumption, that's really difficult to do if you have to physically render everything.
It also allows packaging pieces of this for distribution outside of this room here if we wanted to. So we might want to build a physical head. We could have the animated version of the head as well, and we work with it and allow us to farm out projects beyond those that are physically able to drive to the meeting room and work with it. Work on this project here, this is what you need, here's your animated head. Oh, cool, now we'll actually build the head and match that, etc. So, we have some people willing to do a 3D animated head for us, and I work with that, that'd be cool. So the question I have regarding the neck basically is like, how many degrees of freedom is really necessary to make the neck look reasonable? And we don't know that information. We know how many is in the neck. It's a massive number. We really can't do all of that. Neither can we do all the degrees of freedom and the facial expressions. What minimum numbers required? It's going to be kind of a curve, some type of curve. Get perfect, you need a lot of them. How far can I back off to get reasonable enough? And reasonable enough may vary based upon how far on the project we are. Reasonable enough 2 years from now may be different. Reasonable enough 5 years from now. To have the ability to quickly do what-if scenarios or something that you want to physically build would be very, very nice.
I think there are data sets, like ergonomic data sets, that have all of the different degrees of freedom for the actual body. We have access to anything like that?
That's why you really shake your head. You would think Max Headroom is, weren't you?
Well, when you said a television, I immediately went there, but not because I know they have data sets for ergonomic studies that talk about comfortable ranges of motion and maximum and minimum ranges of motion and all that. But with the neck, it'd be interesting to find out what that is, because I know you can do an enormous number of different motions with the neck, but most of them are being uncomfortable.
Grayson provided us a sheet last meeting, I think, with it. So it's more or less 5 degrees of freedom to for rotate. Let's see, top XY, the bottom XY, and then just rotation. That's 5.
Yeah, but I mean,
We need a physical therapist.
Right, but that's just a combination of
right, I mean,
rotation and then rotation, so it's still more or less 5. And then all the other ones I think we neglect because people won't notice the spinal cord bending like this. They'll just notice that.
Not right away, anyway.
There's also a
And
problem.
don't forget my goal, but to get something built that works.
Right.
And once we get it going and we understand the issues and have experimented, we'll do another one, we'll do another round and here's what we found, here's where the shortcomings are, here's what worked, and we'll do another iteration and another one and another one. So it's important that we understand as much as we can about the problem, but I don't want to spend forever trying to solve things that are going to take us out of the realm of getting something built. So there's a balance.
In the 5 again, you have? In the 5 we had again?
Basically, 3 rotations about the pivot of the skull, and then 2 rotations at the bottleneck, side to side, and then back and forth.
Okay, so, yeah, only rotations when you're trying to actually rotate, and then you basically catch it.
Right, because
These are the
the
neck
rotation
forward
like
back,
this
and
is
then
more like
rotation around top.
then, I mean,
So you want to do weird, like,
Right.
arches and stuff, that's.
right.
Well, a lot of that is probably part of the body, not the
Well,
neck. Isn't it?
there's actually
Yeah, we,
12 different, what do you call it?
Degrees of freedom.
Yeah. Is that term again?
Degrees of freedom.
Yes, 12 degrees of freedom, exactly. There's actually 12, so you're saying that that human head only has the ability to do 5 of those. Actually, the first 6 and the second 6 are like the same thing, but they're like the inverse of each other. So you really can think of it as being 6. So
Okay, I see
the
what you're
head
saying.
can only do 5 of those 6, is what you're saying?
Well, I mean,
Well, obviously, it can't go any farther than that.
right, but I mean, we could approximate the motion, the rotation side to side as just about a single axis instead of having this part rotating this way and this part rotating that way. It's more or less the same as if they're both rotating. Whereas the tilting, this is separate, whereas this is about almost the same as.
Well, can't the neck be gimbaled? You know what a gimbal is? Okay, a gimbal has the ability to do this and this and rotate. So a gimbal is what's inside of a what are those things that keep you level? Can't think of the name.
Gyroscope.
Yeah, a gyroscope. So there's a gimbal inside of all gyroscopes. Because a gyroscope has to have all different degrees of rotation, okay, in order to be able to be a gyroscope. So to me, it sounds like you would need something like a gimbal in the neck, and then you restrict the degrees of rotation that the human body can't do. Look up the term gimbal.
And if you listen to what you're saying, what you're describing again was already right here, which is.
Right, it would be in the neck.
Top of it, and then that's basically was 3, and then we have the second one, 2 more degrees of freedom further down in the neck. So the gimbal plus 2 is what they're doing.
it's the difference between nodding your head and keeping your neck stable. That and that.
Right.
Right? 2 different things, right? Being able to do this and being able to do that,
So that could be like 2
Different
gimbals
things.
sitting on top of each other.
right?
One higher, one
Your neck is
lower.
actually more flexible than that, but it's probably enough to do that as the balance.
Assuming no wreck or accident, basically, I think those are close enough.
Yeah, right. Anything more than that, you probably don't want to do with your neck, typically. So,
Or you'll need a chiropractor.
Right.
I think the reason I was thinking is more complicated than that, but I think you're good on those 5.
I mean, I think we could. 3 is definite. We've seen it in the system that these planning systems use 5. We should still be able to get because there's that bird neck that was able to achieve 5. So it's just a matter of how we're going about it and how much power we're going to use.
So have we answered anything for you as far as timelines?
When can you build it? When can it be
Yeah.
built?
Yeah,
Let's get to the bottom line.
No, next month, fourth of May, that's it for those guys.
I mean, we'll probably end up spending probably around a month. I'm just trying to figure out how things we all start.
Okay. So if I understand things right, there's a new gentleman that's going to join our team. He can join our team this week, or apparently a lot, so sometime. And so he wants to work on this, right?
That's what I heard through the grapevine. I know
Okay.
nothing more than the email, which is.
I think he's willing to do whatever, but he's building some type of control for radar systems or something. So he's doing all kinds of similar things in his real job. So, so he thought he may be able to help in that area. So you need to get with him. And
Yeah, we
find out.
need to talk. I think
Talk and
the four of us need to talk and sort of hash
We
out.
can meet off before, in our next meeting. I will be unavailable from next Thursday to the following Wednesday. So I should get it this month, or she is next month. But you guys are flying down to Florida, in the evening. But, we can meet possibly before then, next Monday, Tuesday, or Wednesday are reasonable, or I should get back. So I just send an email, see what time we're. Thursday, not Wednesday, say Monday, Tuesday, Monday, Wednesday, I'll get back. And then Tuesday, actually, no, Tuesday night, we got the, special belief thing, so Tuesday night and Wednesday night, we're not this guy, we're on Monday night, it's on that little, next week.
It's a holiday, yeah, you're not gonna get anybody.
So let's schedule when we get back. I'm pretty open after we get back.
Come on.
Yeah, let's do.
I think put together an email list, which you described now, which is possibilities of freedom, and then send it out, we discuss that. The other guy, that's where our voice skill sets is, I have nothing about him. Was he at the last social fleet meeting that we have in person or not? I know someone last, I don't think I should have met him, I know we haven't spoken about this at all, but at least put out what you're heading with it, get the other side who does what. I know y'all going, so we've been working very well together as a team, so.
yeah, he's real good to work with. I think you'll find him fun to work with. So. Okay, so keep that in mind, because I'd like to see the head mounted on the 5 degrees of freedom with some control. That's what I think that's something we can demo and show people. Will have an effect. So you're going to talk with your team, Carl, right?
Mm-hmm.
So,
Hopefully within the next.
because our goal for your team is to feed us recognition.
You're not going to get an awful lot in the beginning, but we'll get you something.
That's our goal. That's our goal. We gotta have a goal. So if you can start telling us who we're talking to, that would be big for us. Even if we don't have a lot of the detail, if we can just recognize who it is, then we can establish a conversation. You know, the context that is in. And you guys,
You guys are the same team, right?
Yeah.
Oh, okay.
So
So,
kind of what's your rollout? What are you thinking is kind of your rollout here?
Well, we've got the chat bot. We need to finish hooking that up with the hearing and sort out this, hearing ourself issue, which should be fairly easy to solve if hearing can tell us something about the speaker. Then we've got to start at persisting some of the information. We've got some issues to sort out there in terms of what information we're collecting and how it's being saved, and the fact that it's not actually being saved to disk at the moment, and it's being saved to memory and lost on restart. So some issues to sort out there. And then we've got the general issue of how rich of a conversation can we handle? And right now our conversation's very limited. Of the forum, have we met before? If we haven't met, then what's your name, and tell me some things about you. The idea would be, once we get that kind of plugged in, that we could easily expand that conversation to whatever extent we want. The chatbot configuration is quite simple to do, so it's easy to add to that. How much we want to, whatever we want to put into that is still undetermined. I think while that's sort of waiting for hearing to come along, and vision to come along and provide us some input to drive us to do some other things, we're looking a little farther down the line with some of the things that I talked about today, in terms of how can we take it from chatbot, which is hard-coded input-output patterns, to creating something in between those where we bring in an input pattern and we actually have some intelligence before we produce an output pattern.
Yeah, if you look at that diagram that you put up there for the layers of the AI, the chatbot is essentially that very top layer where you have input, and then it's kind of hard-coded directly over to some output. That's really what's there.
Right.
Everything below that doesn't exist. So, little details, right? But that's realistically, I think you agree that that's where that sits today.
Absolutely.
So there's clearly a lot to do.
Question regarding the audio system.
So I guess my challenge to you for next month's meeting is to have somewhat of a timeline. And I'm not going to pin you down on it, but think about what it is, what resources you need and what skills you need. Right? At some point, I suspect you're going to need coders to go, right? Unless you're planning to do it all yourself. But once you get a design, I would expect that you're going to need some fairly decent computing power, and you're going to need some coders to start coding databases and just logic stuff that you design. So, and you may need power, and I'm not sure, you may need some extra stuff too. So, Carl, so I need you to kind of start laying it out so that we have a vision of what skills I need to go start tracking down, and bodies and people and equipment and stuff. So we're not coming up and say, oh, I can't go on because I need a big computer and I don't have it. So, or you guys need hardware pieces. We need to make sure we have it lined up ahead of time, that where that's coming from, where we can get it. So, so that's what I need from you, is really kind of what's your plan, and what do I need, or what can I do to help you guys solve your problems.
Regarding hearing yourself, something just popped in my mind a few minutes ago, and it's not the way the human solves the problem, of course, but since we control the audio and the hearing and speaking, we superimpose some other audible cues on the voice outside the range of only human hearing. It's picked up by the hearing system right now. That's actually our own voice. We higher pitch frequency, runs towards our width, some of that type is going to be picked up. I mean, it's not what happens with a human, but everybody solves the problem the same way.
Right. Or we could publish a message that says, I'm starting speaking, and then, okay, I'm done speaking, and the hearing system could pick up that message and stop listening during those.
Well, that's assuming that basically we're not listening or talking. It's probably a bit more accurate for human beings, but like human beings, you're able to try to continue hearing while we're speaking to the.
Right.
Well, the notion of priming is essentially, we're speaking this, hand that over to the hearing sim team and say, you really should be hearing this with these intonations and these, right?
Right.
You should hear that. If you don't hear that, then there's something else wrong. But if you do, okay, classify that, and that's me. Right?
Right.
You can pass that to me, and we can, do the feedback thing. But we don't really care.
Adafruit has just come out with a whole new audio soundboard that has all sorts of really great functionality built into it. You may want to. They've just released it like within the last week or so. So you may want to go out to their site. If you haven't been out there in a while, they've kind of like changed their whole site around lately, certainly. And take a look at that board and see what it can do. It may have it may solve some of your issues. In order to not have this feedback loop, the only way I know of that you could possibly do this is to employ a dynamic filter that knows exactly what to filter out while still being able to hear or listen to everything else.
Some kind of subtractive filter, but that sounds more likely to cause problems than just hearing it and dealing with it as a normal voice and then associating it with that person who just happens to be me. That fits into the model of, okay, hear everybody and everything that's being spoken and associated with who spoke it. And
yeah, but if you think about it, that's what your head is doing, right? Your head is filtering your voice so that most of the cognition of your own voice is internal vibration of your own head, which is why you always sound different when you listen to yourself on a tape and you hear yourself speak.
Bone conduction is.
Well, but that's maybe all part of how it's designed, right?
Well, I honestly don't know. I have no idea how our brain filters out what we say, but I suspect that our brain has some expectation of hearing ourselves, and it does, and so it says, that thing that I heard was me. And so it says, okay, that's not important, because I was fully expecting that to happen, therefore, nothing. Whereas if I started speaking and I couldn't hear what I said at all, my brain would immediately go, oh my God, something's wrong.
Yeah.
I don't know what's wrong, but something's wrong, right?
Yeah.
Because I didn't hear it, right? So we get back to this expectation thing, but to me, I think we'd be much better off instead of trying to cancel or filter the thing, just deal with it as a voice and fix the association of, we hear this voice, we process it just like we normally do, and we're expecting to hear this in exactly that voice. And so, great. We prime the audience.
Well, what I'm concerned about, though, is the feedback issue. All right? Just ignoring it doesn't solve the feedback issue. One of the things I used to do was work for FM radio stations. Huh?
There's no feedback here.
Yeah, it's not a feedback issue. It's a cognition issue.
We're not hearing repeating it. It's not like my phone speaker continuing. The voice speaks. The hearing hear it. It's not snipped out again as speech again. It's going into the process.
Oh, I thought you were having issues with feedback.
Well,
I promise you was the person spoke, and then the part hearing heard that as well, trying to process its own.
Oh,
speeches
okay.
it was thinking it was someone else speaking.
It's talking to itself.
Right.
Hearing voices, right?
Yeah.
Hearing voices.
Yeah, it's almost like you expect to hear yourself
Right.
within a certain amount of time. And the only thing that would be different is if you heard another noise that occurred at the same time that isn't matching what you're saying, that's when you pay attention to it. Other than that, you're really subconsciously ignoring it. Yeah.
You do have to do a filter type of thing where you know what your voice is when it's happening.
One
You
more
need a
question,
speech therapist now.
guys. Would it make sense to build the bus neck head structure that wasn't articulated, and then go back and work on the articulation? Or is that make life harder?
I mean, if we just substitute a piece of 80/20 or something for the whole neck, all everything, then we just, it's just an extra stick of 80/20 along with everything else.
If we got the people to do it, we would certainly learn a lot from, mounting some microphones and mounting some cameras and trying to get
Figuring
the
out how much
wires
space we've got for computing power and power supplies.
and actually getting that
There's a
data
lot of
flowing.
stuff that we could build up that would give us information while you go back and figure out how you physically articulate the head.
As far as structure, I think we'd be able to make something where you have like a column that substituting the neck and then just remove that column and then substitute our articulated neck assembly and mount that onto this bus and then mount that on top of that. That would work.
That would have to interface with our joints.
You should do it consistent with what you think you're gonna need between those 2 points, so there's not a lot of rework. But I'm thinking if there was an intermediate step there, that I think it would help the other teams move along. And
We
have
have
work on the actual,
discussed, how much room is the other groups need for their stuff. And I don't think we really know that yet. So yes,
But
you're saying
having the bus there where people can see it and measure may help stimulate some of that discussion. That's what I'm thinking. Right now, it's kind of nebulous, it's just. But if it's physically there, people will start saying, "Oh, how much?"
The vision teams should have 1 or 2 cameras already where there's up there, the audio team has 2 microphones, and I agree with you, but I don't think that point where they review that anytime soon to solve the very basic problems. I'm hearing 2 to 3 month time to actually get a neck built is probably is faster than either the vision or the audio team will be needing something to attach it to. Right now, the vision team is working on single camera inputs and not doing stereo. Audio team is doing single microphone and not doing stereo and recognition, etc. So given that, there's actually need of a head. That's important. I'm not saying we couldn't do that. There's some time of we're using Alan's time and their cost and resources. I'd rather say that.
If you can build the head and the bust, and then put a temporary kind of fixed structure there while you're working on the articulation, it's not really rework or redo, hopefully. If it is, then I don't think it's a good plan. But if you could design basically the shoulders down, then it gives us something physically to look at and to start considering, space and size.
right, will be
Where, this is a basic question, because we're meeting here for all our meetings, but do we actually have a workshop? Where are we going to be building this and putting it all together? Because if the vision's ready or audio's ready or whatever else, and we don't have that structure, that bus for the framework, then my suggestion right now is to start off with generic chemistry lab equipment with acting like third hands and holding the devices where they need to be, and you can tie it all together, test it out with software or whatever else, and then you can integrate it into the bus later on. But do we actually have a workshop? Where is it we plan to build this?
I don't have a good answer.
Okay. Because at that
Initially,
point,
I
then we
think
can start setting
the
stuff
initial
up.
stuff will probably be done at Alan's facility. But I don't, as we get bigger and kind of get working on it, I don't know that that's gonna stay legal. So I actually am looking for some other options.
I mean, I didn't know, like, with your business, you had space, or if, we had another place where we could do work or not. But that was, because obviously we can't do it here.
Right.
So I didn't know if we actually had a garage or something where we could set that up. Because, like I said, if it's gonna take a long time to get that scaffolding for the bust, then my suggestion is go the old-fashioned route using chemistry equipment, coming out with clamps and third hands and whatever else, and then
Yeah.
we can start holding stuff in the places
If
it
we're ready
needs to
do
be,
it, then we can do
figuring out
that.
how to hook it all
I'm
together
just
and
thinking
make
that
it work.
they've got to build the head and the base
Yeah.
anyway. They do that first.
Yeah.
Then that gives us another option.
Yeah, but that doesn't, but that bust does not stop you from being able to figure out and integrate all the different components, vision, audio.
It all depends on how the stuff rolls out.
Yeah.
When it becomes available.
Because, obviously there's a lot of software design, but there's a lot of, we're thinking there's hardware we can use. We can start, like I said, trying to find some of this hardware, seeing how we can integrate the hardware, finding out how to power it, and all those types of things. That could be done on a breadboard type setup to start off with. It doesn't have to look like a head to start off with. We can get that interface done and then figure out how do we fit it into that scaffolding. So, but then, like I said, you need a place where we can start putting all this stuff together.
Oh, I mean, if y'all know hardware-wise, like I want to use this power supply from an Allied, or something, we can grab stuff and start putting stuff in here. I mean, we don't have to wait till we actually get something for real to start putting stuff in.
Okay, you can model it, yeah.
Sure, yeah. I mean, so. Like
I don't think we know what we're going to use yet. That's part of the.
Exactly, but as soon as we get to that point, and you're like, this is what I want to use, and all that, we can put that size in here and start to do all that kind of work without something actually right here, and that may answer some of those questions as you were saying, but I mean, this is so close and so simple and really not very expensive, here for the head and the 80-20, structure. I don't see where that would be expensive or time consuming to produce if we had to actually have something to put our hands on now. And it's pretty much good now.
Yeah, well, this is why I was asking earlier, kind of what's the rollout, where are you gonna be, when, so we can start matching up your schedule, the schedules, and try to start getting them to align. Because right now it's just a bunch of unknowns, like all dimensions. So somehow we gotta start pulling stuff together and
Having a
timeline.
physical data we would have shown this progress being made by the team, being done, a tangible asset was on a computer screen. That much I would agree. I don't think it solves any other team's issues. I mean, I think as was pointed out before, other teams could find ways of testing audio, testing vision, testing everything they want without a head. So the head is not needed for other teams. If the goal is to have something, hey, we got a piece of product, that's what we got, to encourage other people to join us, to show around to people, to get funding, and it's a different issue. So we head down that direction, we need to understand that. If you're looking for other teams, all the other teams needs a head. You can't tell us we look at for other reasons other than other teams, when the answer happens to me.
The answer is yes.
Yeah, that's what we need to hear.
Yeah.
Yeah. I want to start showing something to people that have potential funding opportunities. That
We should have heard it at the beginning. That becomes the answer. It doesn't really matter whether the teams need it or not. If it helps in that area, this could be fabricated.
it helps, yes.
I would say, you know, it's, don't let the thought that the development model has to look like the finished product. I mean, experience-wise, we built the 777 in a warehouse before they ever cut the first piece of metal. And it was rows and rows and rows and racks of equipment, and it didn't look like an airplane. So, you know, if we can start getting products and, you know, start figuring out how to wire it together, you know, and then it gives you something to let your software talk to and things of that sort, you know. I mean, I've run into that thought process where the beta product had to look exactly like the finished product, which means that by the time you got to the finished product, you wish you could have scrapped the whole thing and started all over again, but you've already invested that much into it, you can't change it, you know.
That always
Very
happens.
iterative.
And as soon as you start putting hardware together,
Been there
then
100
you
times.
feel like you're doing something, you know.
Yeah.
Yeah, I think there's good reasons to try to start getting stuff together. I will encourage people to start getting their hardware installed. It gives us something to show to outside people and stuff. And I think we can do it right without really impacting the schedule of the two pieces.
I'd like to hand it off to Alan and make you know that he's involved in building it.
That's right.
I'm not as clear that the head built as of now would be the model to use for the neck. I mean, the neck itself, the motions of the neck, the motors of that neck, and actuators may involve three part of the head into the body, and you just say, well, the head is a done deal, and you build the neck, you kind of limits your actions and what you can push other places.
I don't want to limit.
I know you're not, but I'm saying that's why I was wondering if the goal was to solve the team's problems, and those problems don't exist, it wasn't worthwhile. If the goal was static, clearly built, and that just can throw away the head. The head is not really solving the team's problem, it's solving monetary issues. At that one time, $100 for building a head, and it's a drop in the bucket. So I was trying to figure out what purpose of the head is. So yeah, I'll say turn the head, wrap it up, turn the head over to Alan. You build that, you guys can head on. If you can use the same head going forward, great. If you can't, don't constrain yourself to requiring the head and start working on the neck. I think it's a reasonable way to handle it.
I'm not sure we even have to build it yet until the rest of the pieces are kind of, because if you want to modify it and stuff, that's fine too. But it's, if they're ready, at some point, we'll decide, okay, let's go build these pieces. Then we'll have something, and then, you know, we'll work on this other piece to a certain extent.
Well, I guess we can guarantee at the very least that by the June meeting, the head frame will be available. We'll see if we can get the shoulders too, but head is definite. Shoulders.
Yeah, I mean, we can tweak that and make those changes that we talked about that are very, very small. Export these files out into the proper file types, give them to Alan, and then he can relay those to us. And when you say for him to.
Yeah. Okay. That sounds good.
The shoulders are as simple as just the back on piece of plastic and then over a frame. Maybe need to get the shoulders aren't moving as eventually will be as an opposite. It's just a static shoulder and the neck is attached to it. So you can attach your neck to some sort of base and back and form the shoulders and kind of lay over this and that. That's where you have the form.
Anything else? I guess that's the end of our formal meeting. Welcome to chat, whatever.
Yeah. I want to talk to you about.
So.